Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 122. Minimize length of array using operations. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So you can see this one kind of tanked the contest for me a little bit. I have 4 wrong answers and I just spent a lot of time. I think, to be honest, and this is a little bit of a retro, I was just not awake enough for this problem. It is what it is. I think this is where having your mind just kind of going over how to attack and approach this problem, not just the answer. And I think for this particular problem, how to attack this problem is the way to think about it. And the first thing I noticed for this one is that n is 10 to the 5th. And with 10 is that equal to 5th, then it is going to, my thought is that it's going to be greedy. And I was just trying to think about some greedy ways to do it in n log n at the worst time. But it turns out that I was actually at the very least inaccurate. I think this actually ends up being what I would consider actually an ad hoc problem. I mean, there is a greedy component, but greedy is not the major part. It's an ad hoc problem, and I classify ad hoc problems as just like a problem where the difficult part is not the algo. It is about like sussing out the various edge cases, and almost in a way case enumeration, even though it may not have that many cases, or you know, like you can implement ways in which there are more cases. But that's how I got the 4 wrong answers, is that I was thinking about variations of greedy, and I thought it was an algorithm problem, or like, not that this isn't an algorithm problem, but I thought this was a problem where you have to figure out the algorithm, and you know, where this is actually a problem where you have to, it's a more of a logic problem, I think is the idea. And this is more of a problem where you have, it's like a problem solving logic-y, mathy problem in that way, even though there's no math to it, or there's minimal math, or at the very least the math can be confusing and kind of throw you into a thing if you haven't done it before. And to be honest, I think this, if you want to watch the live video, and you know, if that's interesting to you, this is actually, you know, like I think I talk about some stuff like in the past where we talk about, you know, properties of different things like bitwise functions and stuff like this. But this one, it is another thing that, you know, if you want to see how I attack a problem, and apparently today not so well, but attack a problem that I haven't seen the property before, then this is it. Right, and there actually is a very good observation here for this problem that makes it trivial, and I don't mean trivial as in it's easy, just that it is, you know, once you get that observation, everything else just kind of falls into place, right? But I didn't make it. So the first thing that I tried to do was I thought that I think given this operation, right? I think the first thing that I noticed, it is an observation, but it's not the big one. The first observation is that you know, given this combined with this, you don't want zeros, because zeros you cannot get rid of, right? So you want as few zeros as possible. I think that's the first observation. And then second thing is that given this function, num sub I mod num sub j, and this took me a while, is that if you have the smaller number in front, then it can never be 0. Oh, that's not true. Well, I mean, unless they're equal, right? So that makes it so that I was like, oh, so, you know, you just sort it and then you just take, you know, numbers off the end. I did try to play around with that, and if you see it, I think I got like 2 or 3 wrong answers just off that, because I thought that you just take the 2 biggest numbers and then just kind of keep modding it, or not. It's modding, but you actually just remove the bigger number as long as they're not equal. But then I kind of ran into a couple of edge cases with that, which can be handled, but I just didn't. Like, I could handle them individually, but it may actually have taken like 5 more wrong answers before I like kind of go through all of them, because I don't know, my brain just wasn't really in the groove for these kind of problems. And it was before I recognized that it was this kind of problem, and like, no, Larry, it's not it's not an algorithm thing where you'd be like, oh, it's just like a minor edge case with a very general algorithm. No, it's a problem where you have to think through, like, it's a logical problem, like I said, right? And as a logical problem, I just didn't like, oh, I actually have to spend time on this instead of just like going on instinct, which, you know, and this is something that is just like maybe particular to myself and knowing myself and how I attack these problems. And yeah. So yeah, given that, like I said, if you have given two numbers, you want to just keep the smaller one because either they're the same. If they're the same, you get a zero anyway. If they're not, then you keep the smaller number, and it cannot be zero. The only way that it could be zero is if they're equal, right? Where if you chose the bigger number, then you have this multiple thing, right? Like you have 3 and 6. 3 mod 6 is 3. 6 mod 3 is 0, right? So that's no bueno. Um, yeah, and and from that, and it took me a while, and I think three wrong, or well, yeah, a couple of wrong answers later, I was like, oh wait, why am I doing this? Let me settle down a little bit. And I still got a wrong answer after this, but I was just like, oh, we could use the smallest element, right? Why? Because the smallest element is guaranteed to, um, well, it is just going to be the only one that remains, because if you choose the smallest element and any other element, you could choose the smallest and the biggest, and then um, uh, uh, if you choose the smallest and then the biggest, in a way, um, if you choose the smallest and the biggest, in a way, you could induction it. Use It's an induction, but like you could iteratively or recursively, maybe that's a better way of thinking about. Take the smallest and the biggest, and then remove the biggest and keep the smallest, right? And then you could go through the entire way. That's if everything is unique. So then what happens if you don't have unique? Then, like for example, in this one, you just kind of match up the zeros, right? But it actually, so that is 90% of the cases, is that you take the smallest number and then you just remove the biggest number one by one, and then you're left with this with the smallest numbers, and then you have to do some like zero counting thing, because it could have two zeros. But it turns out there's actually one more edge case, one more logical case, which is that it's not actually in here, but the one more case is if you have something like, I don't know, 5, a lot of fives, and a bunch of numbers. They should not be smaller than 5, but you get the idea. And then the idea here is that, okay, you take the fives and then you remove all these, right? That's my previous logic. You remove all these, and then now you have all these fives, and then you have to count the number of them to get zeros, and it's just like divided by 2, round up or whatever, right? Easy math on that part. But it turns out that there is actually another way of doing it, which, if I didn't get so many wrong answers before, this would have been kind of nice. How did I get so many wrong answers? Just lazy, I think. But yeah, is that, you could take, if any of these numbers mod 5 is not 0, then obviously if you mod 5, you always get a number between 0 to 5, but you don't want a 0. So that means that if any of these mod 5 is not equal to 0, then you get a number less than 5, right? So let's say 351, now you get 1, and then you get everything is the same, right? Except for me. So you remove the 351 and you remove the 5, right? So now you have a unique, because by definition you look at this, you have to count the smallest number. The new smallest number, you're only going to have one number, one unique instance of that smallest number, and because of that, then you just remove everything else, and now you have 1. So that's basically the idea behind this problem. That's the big observation, is using the smallest number, and then there's some edge cases of the smallest number. Like I said, I just kind of, I thought it was more of an algo problem, but it turns out to be more of a logical problem, and I think it took me a couple of wrong answers to really switch gear and really think it through and follow through. Because I just thought, like, hey, maybe it's greedy and maybe I can prove it. And I think the other way is kind of right, but it's just there are more edge cases, and I just couldn't get through all of them. Yeah. But as soon as I realized that it wasn't the right approach, I had to stop myself. But I did really get a lot of wrong. I got 4 wrong answers on this one. I don't even. I guess on this view they don't really show you what the wrong answer is, so I can't show you right now during the contest. But yeah, but obviously this is going to be linear time, linear space. I don't even. Well, the way that I did it is linear time, linear space. But you actually don't. You could do it in linear time, linear. sorry, you could do it in linear time, constant space, because this does not need to be an counter. You could just do a count. You get the min, do a count to loop through the array, and then to get this, and this is just if if you have this case, for example, case 2, where everything is either the min element or if you mod it, it's going to be 0. So yeah, and if you don't have, and this so this is if all the numbers, the min numbers are the same, or the number of count of the min numbers, and this is if you could get a smaller number, that is, if you can get a smaller number than min, and get one unique instance, right? Then now you can return 1 because you can just use that number to mod everything else. But yeah, a messy problem for me today, but that's all I have for this one. Let me know what you think, and yeah, you could watch me make all those mistakes with all the wrong answers next. My audio, I didn't. I think I was switching mics and it didn't get picked up on the audio. So even though I do say stuff, but you don't see it, so I don't know. It is what it is, but it may be interesting. Let me know what you think, and yeah, you could watch me solve it live in contest now. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.